titled Graphing Form of a Quadratic Function. It's going to cover pages 4 and 5 and answer the question, what does the equation reveal? Starting with question number 23, Anissa is looking over her work from the parabola lab. That's what we worked on yesterday in your groups of 4 where you guys were graphing in Desmos. Okay, she wrote down the equation, g of x equals x minus 3 squared minus 4, but she cannot find the graph to go with it. Based on what you discovered in the parabola lab, you're going to sketch the graph g of x equals x minus 3 squared minus 4 and describe how it is transformed from the graph f of x equals x squared. That's our parent graph that we started with yesterday, right? It's just your basic parabola. It's not shifted right or left, not shifted up or down, not skinnier or wider, not reflected, just your plain old parent graph, okay? Where is the vertex of the parent graph f of x? And where is the vertex of the transformed graph g of x, okay? The plain old parent graph is just at 0, 0, right? It's right in the middle, just goes up nice and pretty, not moved, not stretched, nothing, okay? So, if we change our parent graph to x minus 3 squared minus 4, it's going to take our vertex and move our vertex 3 units right and 4 units down. That puts our vertex at 3, negative 4. We get those numbers straight from that equation. Where that 3 is, that's going to be the x value of our vertex. And where that minus 4 or negative 4 is at, that's going to be the y coordinate of our vertex. Any questions on part A? All right, part B, we're going to determine the x and y intercepts of the parabola from Anissa's equation. And they want us to show our work. Okay, so for part B, to get the y-intercept, we're going to substitute 0 in where we see our x. There's only one x, so we plug it in there for our x, and then we calculate it using our order of operations. So we need to do our parentheses first, our exponent next, and then do our subtracting, or sometimes it'll be adding. Okay? So 0 minus 3 is negative 3. Then we take that negative 3 and square it to get 9. And then 9 minus 4 is 5. That's our y value of our y-intercept. X value is 0. That's what we plugged in for x. Okay? Now we're going to flip-flop. If we want to get the x-intercepts, we're going to plug in 0 for y, okay, which is the opposite of what we did over here. Over here, we plugged in 0 for x, okay? So we set the equation equal to 0, and then we do inverse operations until we get our x by itself. So the inverse operation of subtracting 4 is to add 4. We're going to add 4 to both sides. Then we have x minus 3 squared. So the inverse operation of squaring is square rooting. So we take the square root of both sides, and then we have 2 solutions here, a positive one and a negative one. The square root of 4 is 2, but it's also negative 2. So we set it equal to 2 first, add 3 to get the x by itself. That gives us an x-intercept at 5, 0. To get the other one, we set it equal to negative 2. Add 3 to both sides, and we end up with positive 1. That gives us our other x-intercept at 1. This is 1 point, 2 points, 3 points. That's 3 points to help us get started on graphing our parabola, which we're going to do when we get down to part D. Okay? So already 3 points. That's almost enough to completely see where our parabola is going to go. All right? Part C. Rewrite Anissa's equation in standard form and in factored form, and what information does each form of the equation reveal about the graph? Okay, so her equation is x minus 3 squared minus 4. We're going to FOIL this x minus 3 squared out and then subtract the 4 from the 9. And we end up with x squared minus 6x plus 5. And that puts our equation in standard form. Then we take our equation from standard form and we can factor it. I factored it using the box, but you can do it other ways. Some teachers have different methods, but basically we end up with x minus 5 and x minus 1. That's called factored form. So this is standard form, this is factored form, and that up there, wherever it was vertex form. So we've just seen that same equation in 3 different forms. Okay. Part D says, sketch the graph using the information from the factored form in Part C. Which form of a quadratic function do you think is most useful for sketching? Well, we're going to use parts from all of it. So if we have factored form, you can get your x-intercepts. One is at the opposite of this number, 5, 0, and one is at the opposite of this number, 1, 0, or from our vertex form, we can get the vertex at 3, negative 4. So you go 3 to the right, down 4, and that's your vertex. So it just depends what form will give you different information. Once you get the vertex, you can find your line of symmetry. It should go through that vertex, and then everything on the left should match up to everything on the right. The left side should mirror or reflect the right side, okay? Then you can pick a couple other points and plug in the number, and whatever you get out will be your y value. So if I picked 2 and I plug it in to the original equation way back up at the top, our 2 minus 3 is going to be negative 1. Negative 1 squared is 1, and then 1 minus 4 is negative 3. So we fill in a negative 3 here. So if we go 2 to the right and down 3, we have this point on the left side of the line of symmetry. We should automatically know that we should have a matching point on the other side of the line of symmetry. So if we have a point at 2, negative 3, which is 1 unit this way, we would just go 1 unit this way, and we should have a point at 4, negative 3. They should match up, okay? That's what symmetry does to you, okay? Part E says a function in the form f of x equals a times x minus h squared plus k is said to be in graphing form with a locator point of hk. For a quadratic function, another name for this form is vertex form. Why is this name appropriate? Because it gives you the vertex. Graphing form gives you the vertex. That's why they call it vertex form. The name is what it is. So it ends up being at HK. Any questions on part E? Anybody still writing? Okay, flip over to the top of page 5. And let's look at question number 24, which says, in problem 23, you rewrote Anissa's function from the graphing form to standard form. How can you reverse this process? Consider the function x squared minus 6x plus 5. What algebraic method can you use to rewrite this function in graphing form? Okay, so we can factor the x squared minus 6x plus 5 to get the factored form x minus 5 times x minus 1. You can use a little box. There's just not a space to do it right there. All right. Question number 25 says in chapter 5, you used the process of completing the square to rewrite quadratic equations in perfect square form. For example, by completing the square, you rewrote the equation x squared plus 4x plus 1 equals 0 in perfect square form as x plus 2 equals 3. The process of completing the square can also be used to rewrite a quadratic function in standard form into graphing form. Rewrite each of the equations below in graphing form Record your steps and state the vertex of each parabola. Okay. A and B are fairly similar equations, and they have very similar processes. But if you have a highlighter, I want you to highlight the 6 in front of the X in both A and B. We're going to do the same process on both. It just ends up that they're both 6. Why they use the same number twice, I don't know. Anyway, you're going to take that 6 and you're going to take half of the 6, which is 3. That becomes your number inside the parentheses that you're going to end up squaring. Okay? So you're going to factor, you're going to take half of whatever that is, write it in the parentheses below the square. Then you're going to, whatever number is here, rewrite it. Then you're going to subtract the 9 that you just added there. These happen to be opposites, so the number being added after is 0. Now we don't generally write 0, but just as like a placeholder, put it there so that you know that your vertex is at -3, 0. Okay? All right, for part B, we have the same coefficient of 6, so when we take half of it, that becomes our number inside of our parentheses that's being squared. Bring down that number, and then we need to subtract the 9 that we just added. So 1 minus 9 is -8. That means you have a vertex at the opposite of this number, which is -3, and at this number, which is -8. Okay, so we're getting our vertex from this vertex form, right? So the directions for number 26 want you to, with your team, complete the square for each function below so that it is written in vertex or graphing form. They want you to use algebra tiles. I'm not going to have you use algebra tiles. I'm going to have you use your Desmos graphing calculator. Okay? Then you're going to sketch it, and, well, that's what it's going to have you do. Okay? So let me